Good morning or afternoon, and welcome once again to the North Mac High School Algebra 1 EOC video clips. This video clip is 4.03 Systems of Equations, video clip number 11. Again, 4.03 Systems of Equations, video number 11. Alright, number 1 says graph the solution set. You're given a system of inequalities that you need to graph. You have x minus 2y is less than or equal to 10, and 2x plus y is greater than 0. Alright, first, solve for y in each one of your inequalities. When you solve for y in this inequality, you end up with y is less than or equal to 10 minus x divided by negative 2. Because you're going to move your x over, you're going to subtract x and divide by negative 2. This is subtracting x and divide by negative 2. Negative 2. The second equation, you're going to solve for y as well. You end up with y is greater than 0 minus 2x. Now, in the first equation, you may be thinking, why didn't we reverse that inequality there? When we divide by a negative number, we do need to reverse that inequality. So greater than or equal to. Greater than or equal to for that. Alright, so now I'm going to take the inequalities. I'm going to put them one at a time in the graphing calculator. So I have y equals. Now the graphing calculator will actually do all of your shading and everything for you. But I'm just going to type it directly in and do the shading. So for the first one, I'm typing in y equals 10 minus x divided by negative 2. 10 minus x divided by negative 2. I'm going to hit graph. My graph comes up. I'm sketching my graph. Alright, and then it says y is greater than or equal to that. So I'm going to leave it as a solid line because of the equal to, and for greater than, I'm going to shade above the line. Shade above the line for greater than. The second one, I'm going back into y equals. I'm going to type in the second function now. 0 minus 2x. Hit graph. That graph comes down through 0, 0, and it says y is greater than that. So I'm shading above that line. Now the overlap, you can clearly see, I hope you can clearly see that these two graphs are overlapping in this area. That means that that area, that region is your answer. That area, this region where they overlap, that's your answer. So all I did was graph this one, and where they overlap is your answer. Now, the thing I want to make with that second line is it does not say equal to. So this second line is really a dotted line and then shade above. A dotted line and shade above. So again, you solve for y, graph it, shade above. Solve for y, graph it, shade above. Why was I shading above? Because both of these were greater than, meaning shade above. Now there are some times where you would check a point in the region, and we can do that to make sure that that region is correct. We can go into the region, grab a point out of that region, any point in this region, and that point has to check in both of these equations. And what I mean by check is when you plug the x number in and the y number in, it has to be less than or equal to 10. When you plug the x number in and the y number in, it has to be greater than 0. So you can go into the region, pull a point out, and check it. Problem number 2, a word problem in reference to systems. It says a restaurant is able to seat 62 people at 23 tables. If a table seats 2 or 4 people, how many seat 4? Alright, so we're going to let x is going to represent the 2 people tables. And y is going to represent the 4 people tables. You can see your two things. You can see that you have 2 people tables and 4 people tables. Now that sounds kind of funny, but that's really in most restaurants that is the case. You have little tables where 2 people sit or tables where 4 people sit, and in some cases you have booths but 2 or 4 people tables. Now there are 23 tables in all. So X, the number of 2 people tables, plus the number of 4 people tables, equals 23. Again, X plus Y equals 23, because there are 23 total tables. Now, you're going to have in your system word problems, you're going to have 2 things going on, whether it's 2 adult tickets and children's tickets or whatever, but you're going to have 2 things going on, that one be X, the other one be Y. Then you're going to be given a total, and then you're going to be given something else to set up that second equation. And that second equation is equal to 62, but be careful. There's 62 people total, and that means that you have 2 people for each X table. So 2X plus 4 people for each Y table, 4Y. That problem is a lot of times you'll see it as money. They'll say dimes and quarters. And this is where you would say for dimes 0.10 and quarters 0.25. So again, X plus Y is the straightforward one. It's the sum of the 2. And 2X plus Y, 4Y equals 62. Now, with this problem, you would then just proceed to solve the system. Solve the system. But my point here is how to set it up. How to set up a word problem. Again, you're looking for the 2 things because you're going to have 2 things, so you can have an X and a Y. So you're looking for the 2 things. And then you're looking for a total, X plus Y equals 23, and another number that you're going to set it equal to. But make sure that if that number represents something like people, that you use 2 people per 2 people table. 4 people for 4 people table. Same thing with adult tickets and children's tickets. If adult tickets are $10 and children's tickets are $5, this is the part where you say 5X plus 10Y equals $400, or whatever the case may be. All right, problem number 3. Here I want to go on to solve a system. Solve a system. Now, there are many ways you can solve a system. You can go back up here and solve for Y, put it in on the graphic calculator, watch where they cross, and where they cross is your answer. They may not cross. If they don't cross, no solution. Okay? But this problem, I'm going to use method of elimination to solve it. I'm going to eliminate Y. I'm going to multiply the top by 3, the bottom by 2. Again, I'm going to multiply the top by 3 and the bottom by 2. Now, since both of these signs are the same, I'm going to subtract the 2 equations and draw my line. Now, I'm going to show that multiplication. 3 times 3x is 9x. 3 times negative 2y is negative 6y equals 3 times 1 is 3. So I multiply the whole equation by 3. I'm going to multiply the whole bottom equation by 2 so that I have 10x minus 6y equals 8, and I'm going to subtract the 2 equations. Now, when I subtract the 2 equations, I'm going to say 9x minus 1x. I'm coming straight down. 9x is minus 1x is negative 1x. Negative 6y minus 6y is negative 6y plus 6y, which is 0. And then this is equal to 3 minus 8, which is negative 5. Divide both sides by negative 1, and x is equal to positive 5. Now, once you have x equal to 5, you can go back to any of these equations, either one of these equations, to solve for y. So you have x equals 5. All right, so now we have 3 times 5 is 15. Minus 2y equals 1. Subtract 15 on both sides, you get negative 2y equals negative 14. Divide by negative 2, you get y equals 7. We're done. We have the x value, we have the y value. And of course, you can record that as an ordered pair. The ordered pair would be x, which is 5, comma 7, which is y. 5, comma 7. Now, what that means is that 5, comma 7 is supposed to work in this equation and that equation. It's called a simultaneous solution, which means that it is a solution to both of these at the same time. So I'm just going to check it. 3 times 5. This means x is 5. So 3 times 5 is 15 minus 2 times 7. 2 times 7 is 14. 15 minus 14 is 1. So that checks. Let's try 5, comma 7 in the bottom. 5 times 5 is 25. Minus 3 times 7, which is 21. 25 minus 21 is 4. So 5 comma 7 is the answer. It is a simultaneous solution. It works in both equations. Again, this is method of elimination. To solve a system, I'm going to put here that you can use method of elimination. You can solve by graphing. And you may be exposed to substitution already. There are many ways to do it. It's your job is to choose one of the ways, okay, and then find the correct answer. And I've already told you that when you're solving a system, you may get one answer, an ordered pair. You may get no solutions. A problem could yield no solutions. Or a problem could use or yield many solutions. Okay, now when you have this, your graph, these two lines crossing, no solution is parallel lines, and many solutions, you end up with one line. So here you have 3 additional problems. 1, graph the inequality, just like we did before. Number 2, set it up. You have your 2 things. You have a half-hour lesson and a 1-hour lesson. And then number 3, solving a system. And again, you can solve a system of equations by method of elimination, graphing, or substitution. Choose one, get it right. Thank you so much, and have a good afternoon.